Hey everybody, Rob Coe here, talk a little bit about what's new in Inventor 2011. In this episode, we're going to talk about the new frame analysis tools inside of Inventor. Now, the frame analysis tools are now fully integrated in with the frame generator. Frame analysis is going to offer a complete end-to-end digital prototyping environment. We're going to sketch out your frame structure, create the detailed design with frame members from our existing extensive library, and then quickly simulate the response of the frames to gravity and other loads in an easy to use, easy to understand environment. Let's take a look at what we've done here so far. We brought it into the new frame analysis environment, and as you can see, we can go ahead and change the scales of the nodes and the loads so that it gives us a little better view into the analysis, and it doesn't necessarily clutter up the screen with a bunch of icons, if you will. So let's go ahead and set the gravity, important in analysis, especially in frame analysis, of course. And let's first go through and add a fixed constraint. Now, take a look at this. Floating your cursor over the icon, you're getting a real nice animation as to how to place this fixed constraint. So as you can see, grab that beam, place it at the bottom, click on the node, and just right click and repeat. Now you can also use the space bar to repeat your command to just continually add these fixed constraints right there on those nodes. Alright, now that we've got our fixed constraint, let's move on to the rest of this. Let's go ahead and add a continuous load. Now as you saw, this thing's going to hold up a pretty big robot, and that robot's going to be moving around, so this frame needs to be fairly robust. So let's go ahead and add a continuous load, and notice that I have the ability to control the magnitude, the direction, as well as the force that this continuous load is going to be bearing on this frame. So let's go ahead and adjust the angle here, and then determine the magnitude. Now, bouncing back and forth between the nodes is basically what changes your inputs, right? So as you can see, I've got the continuous load on that, and let's just go ahead and simulate the results. Now let's take a peek at these results. As you can see, we zoom in here. We've got our displacement, and we can change the display to actual one-to-one, deformed, and so on and so forth. And of course, we can animate the results. So go ahead and click play here, and as we can see, as that load is applied, we can go ahead and animate the displacement. Now let's take a look at what other tools that we have to analyze the results. So if we expand here, we've got normal stress. Let's take a look at that. And we can see that there's quite a bit of stress on that. So let's go in and change the display of this and add a diagram to our results. Determine what we want for normal stresses, for shear stresses. Select the specific beams that we want to further analyze, so we can figure out, well, how are we going to address this problem? We've got a significant amount of deformation and normal stresses on this particular beam, as well as the other one, obviously. So how are we going to address this particular design challenge? I've received now all the information that I need from the simulation to go ahead and make the appropriate design change. So let's go ahead and finish and go back into the modeling environment. I'm going to go into my frame generation tools. Let's go ahead and turn on our skeletal model here. And let's go ahead and insert a frame from our library. We'll simply change our standard, determine which family we want to pull from, and then determine a size. Now once the size is selected, we simply select on the line there to place this component into the assembly. It's not like we had to draw the profile, extrude it, and then position it relative to the rest of the components. The frame generation tool allows me to grab from a standard library and quickly and easily place the component into the frame and integrate it in with the rest of the design. So I've added my two members, and as you can see, it's taking the entire length of that line. Well, that's not necessarily what I need for this component, so what I need to do is I need to trim it up. And again, with the frame generation tools, I have tools that allow me to trim to frame or miter corners or perform a notch. Here, I simply need to trim to a certain face. So I'll select the two that I need to trim, select the surface that I want to trim it to, and choose OK. Alright. So now that I have my frame all trimmed up here and I've added an additional framing member to it, let's go back in our frame analysis tool. Now it's going to reanalyze, see if there's any changes to it. Again, automatically applying the changes to this simulation, and simply hit the simulate button again. Now I'm going to get my new results based upon the changes in the design. As you can see, this environment, this frame analysis is fully integrated into the frame generator. It was able to recognize all the changes, significant difference in my displacement, significant difference in my normal stress, and now I have a much more robust frame to support the loads of that robot while it's in action. So as you can see with Inventor 2011, we've got features enhancements to simulation and visualization, including the ability to record animations of displacement and stress results over time. You can produce video output of the displacement animation. After running the analysis, you can take advantage of the report generation tools to present your results and embed graphics and animation into your reports.